Multiple choice question, section B. Question 9. Which of the following compounds would form an orange-red precipitate when heating with a failing solution? So let's just look at the key functional groups. That's a nitrile. That's a nitrile group, CN. That's a carboxylic acid. Definitely won't react with failing solution. That's an aldehyde. And that's a ketone. And this is just testing your knowledge on tests. And one key thing is that ketones don't react with failing solution. Neither do carboxylic acid, neither do nitrile. So the answer is C, aldehydes. Question 10. Pentane nitrile can be made by reaction 1-bromobutane potassium cyanide, which is the correct name for the mechanism of this reaction. Electrophilic substitution, no, this is year 1, that is in year 2. Nucleophilic addition, that's in year 2 as well. And obviously you wouldn't have gone through this if you were doing this paper. Well, obviously if you're doing it in year 2, like I am, then it's going to be a lot easier because you can just cross out those two. Electrophilic addition, nucleophilic substitution. Well, what is happening? We're swapping this cyanide group to form with this to form pentane nitrile. It's going to be nucleophilic substitution. And if you still struggling to draw it out, 1-bromopropane, draw it out, cyanide ion, and you can then see that it's going to be nucleophilic substitution to form pentane nitrile. Propene can be made by the dehydration of propan-2-al. What is the percentage yield when 30 grams of propene are formed from 50 grams of propan-2-al? What is the percentage yield when 30 grams of propene are formed from 50 grams of propan-2-al? So this is being formed from, so we can find out the moles of propan-2-al, mass over mR. No 0.8333, 8333. Moles is mass over mR. Mass is moles times by mR. So the mass of propene is going to be the moles. 0.832 times by mR. 35 I get. 35 grams. So this is, what is this called? This is a theoretical yield. And how do we do that? Well, we work out the molar ratio and then we times it by its mR. And how do we work out a molar ratio? We work out a molar ratio of something it was bonded to, so propan-2-al. So now the actual yield is at 30 grams. And percentage yield is actual yield divided by theoretical yield times by 100. So 30 over 35 times by 100. And should get 86%, 85.7, so 86. Sulfur dioxide is produced when some fossil fuels are burned. Which following statements is true? Sulfur dioxide can be removed from waste gas and power station by acid-base reaction with carbon monoxide. That is definitely true. Some of these multiple choice questions, like you don't even need to they just add these just to confuse students, obviously, but you only need to know the key details of the topic and you can easily get the question right. In this case, there's two reactions of sulfur dioxide with calcium oxide, and there we go. It's A. Which of the following is correct mechanism for formation of 2-methyl butene from 2-bromo-3-methyl butanol? So let's look at in that in detail. We're forming this. What is this? An alkene from a halogen alkane. Now, that's definitely not going to be nucleophilic substitution. That is not going to be elimination. Actually, no, it is. I mean, it's not going to be. Yeah, it's going to be elimination. Anyway, let's look at the curly arrow. So, okay, this is actually a bit tricky. In A, OH minus acts as a base, takes a proton. Once formed double bond, CBr bond breaks. B takes proton, but we're trying to form 2-bromo-3-methylbutane. From 2-methylbutene, that's what we're forming. And if this mechanism does occur, well then we'll form 1, 2. We will form 2-methyl. It'll be 2-methyl-but-1ene. So that's not what we want. So it can't be that. That's how I'm going to look at it now. In this case, the acid base takes a proton, forms a double bond, left carbon has a spare electron, CBr bond breaks, and the alkene is on the second carbon. So it is but-2ene, and the methyl group is on the second carbon. So therefore it must be B. And if you look at C, takes a proton, and what actually should happen is curly arrow should try to reform a double bond, not go to carbon, so it should go here. So that's completely wrong. And in this case, well, that is just nucleophilic substitution, so it can't be that as well. An organic compound is found to contain this much carbon, this much hydrogen, this much oxygen. Which following compounds could this be? So we're gonna have to actually, let's not do that. Find out the moles. Moles is equal to the mass of MR. So I'm just gonna find out the moles. In this case, the mass of each of these is carbon is 40. So the moles of carbon is 3.3332, and that's carbon. To hydrogen, well, that's 6.7. Reason being is hydrogen has MR of 1. They're 1, 1. So 6.7 divided by 1 is going to be 6.7. And oxygen, 53.3% oxygen, 53.3 divided by 16, 3.33125 divided by smallest molar ratio. So in this case, it's going to be that. So it'll give me 1 to 6.7 divided by 3.33125. 1 to 2 to 1, obviously. So that tells me it's CH2O. Ethanol, let's draw that out. Well, actually, it can't be the ethanol. Or can it? Ethanol, let's draw it out. Methane. Ethane's got an alcohol group. C2H, 1, 2, 3, 4, 5, 6, C2H6O. Yeah, cannot be simplified. Ethanoic acid. It's not ethanoic acid. If you draw that out, methane, ethane. So it's got carboxylic acid, C double bond O, OH. Methane, ethane. It's obviously got it's gonna have a formula of C2H4O2. Therefore, it is ethanoic acid, because if you divide that by 2, you will get CH2O. The answer is ethanoic acid. I feel like the mistake is that students would be like, including myself, well, this has got 1 carbon, and ethanoic, well, that's methane, ethane, so that's going to have 2 carbons. That's going to have 2 carbons, so it can't be A or B. However, it can be simplified. You know, that could be the molecular formula of it. That's the empirical formula. Well, that's our empirical formula. Question 15, the repeating unit of a polymer is that. Which of the following molecules will form a polymer containing this repeating unit? They're all alkenes, aren't they? So methane, well, that's what's the longest carbon chain? 1, 2, 3. Methane, ethane, propene. So it can't be any of these then. Butene is, and it's obviously got a methyl group, so it's methyl propene. 16. Which of the following statements is true? Position A represents the mean energy of a molecule in the container. Addition of a catalyst moves position at EA to the right. The area under the curve to the right of EA represents the number of molecules with enough energy to react. That is absolutely true. The position of peak. Well, let's look at A. Well, obviously I've already worked out C is correct. Let's look at A. Position A, that's the most probable energy. Addition of catalyst with position EA to the right. No. It would move it to the left, in fact, because it means there's a low activation energy. So the answer is C. Question 17. Which of the following could represent this reaction? C14H30. We form one molecule of tetradecane decomposed to form one molecule of hexane. What's hexane? C6H14. And 3 more molecules. So it already can't be C, that's pentane, and 3 more molecules. So it decomposes to form 1 molecule of hexane and 3 more molecules, but that's only 1, 2, so it can't be B. So now we're just going to have to look at these and look at the carbon, hydrogen, are they balanced? 6 plus 4, 10, 10 plus 4, C14. Hydrogen's 14 plus 8, 22, 22 plus 8 is 30. So the answer is A. Man, these hydrogens definitely won't balance out then. Look at it, it's C78, yeah, C14H 20, 32. So yeah, it can't be D as well. You need 30. Structure of cyclohexene is shown. Which of the following is a general formula of cyclic alkenes such as cyclohexene? CnH2n plus 2. Definitely not that. That's for alkanes. CnH2n, that's for alkenes. It's for cyclic alkenes. So which one is it? It is B, CnH2n minus 2. CnH2n minus 2. Question 19. A and B react together. This reaction was the total amount of moles of substances in equilibrium. Mixture. How many questions do you have left? Okay, not that many. So I'm gonna try to be a bit quicker now. Okay, so we'll draw them out. We'll draw out a table. I, C, E. Initial moles, change of moles, equilibrium moles. We've got A, B, C, and D. A, B, C, and D. We know mixture of 10 moles are left to each equilibrium, so we've got 10 here, 10 here. The equilibrium mixture contains this much moles of B, 4 moles of B, so that's equilibrium moles. So it's decreased by 6. But that's a 1 to 3 molar ratio. So if that's decreased by 6, that's going to decrease by 2. We've got 8 here. However, if it's decreasing on one side, it's going to increase on the other side. So for C, the initial moles is 0 and 0, C and D, because it doesn't tell us the initial moles, so we're going to assume it's 0. And instead of minusing 2, we're going to add 2. We're going to have 2. And for D, well, that's a 2 molar ratio, so instead of adding 2, we're going to add 4. So that's 4. And now we're going to do 8 plus 4 plus 2 plus 4, which is the same as 8 plus 4 is 12. 12 plus 2 is 14. 14 plus 4 is 18. And that is the number of equilibrium moles. Yeah. It does look a bit, no, is that worth 1 mark? It's definitely not, but better to be safe and get the correct answer than, do a quick method and get it wrong. M of hydrated copper sulfate is that. Which of the following is a mass of hydrated copper sulfate required to make this much of this? So I think, let me just double check. I think I know what to do. I think we have to find out the moles of this, moles of concentration and volume, and then yeah, and then moles mass of mR, so mass is moles times by mR. So we're going to do moles is C times by V, where C is concentration and V is volume. So in this case, it's going to be 50 divided by 1000. Convert into its correct units, moles per DM minus cube, times by 0.400. That will give me 0.02. And obviously moles is mass over mR, so mass is going to be the moles, 0.02 times by 249.6. My answer times by 249.6, and that will give me 4.992. So the answer is D, 4.99 grams. 21. Which of the following shows that equilibrium yield of hydrogen and the value of the equilibrium constant are affected by the changes shown? It tells me the forward reaction is positive. Delta H is positive. That tells me the forward reaction is endothermic. So that's just a key thing. We might need to know that for this question, to answer this question. So increase the pressure, the effect on the value of Kc decreases, and the effect on equilibrium yield hydrogen decreases. That might be correct, I don't know, but I know that is incorrect, because only, let me write here, only temperature can affect the value of Kc, and just by using that key fact that you should definitely know off by heart, I can actually just find out the answer immediately now. Well, not immediately actually, so it can't be A and it can't be D, because it says the effective value of Kc increases. Only temperature can affect the value of increase. So we're left with B and C. Obviously, this one it says no effect, which is true. Catalysts have no effect on Kc. Only temperature can affect the value of Kc. However, it says effect on equilibrium yield of hydrogen increases. That's false. Reason being, and it's better to know the reasoning, because then next time a question like this comes, a whole lot easier to attack it. Catalyst increase the rate of forward and reverse reactions equally, hence has no effect on equilibrium yield. So the answer must be C. And just by, I didn't have to, look at the reaction and then trial and error, just by memorizing two facts. Catalysts have no effect on equilibrium yield, and only temperature can affect the value of Kc. And you should know those as well. Question 22. Some enthalpy data is given in table 3. Use the information table 3 and stated bond enthalpy chain to calculate the missing bond enthalpy. Okay, so we are using this equation. I was a bit confused as well for a moment. So we're trying to find the missing bond enthalpy of C double bond O. Which is that? We'll say that's Y. Well, because we're using bond enthalpies, delta H equals bonds broken, or energy required to break bonds, minus bonds formed. Delta H is, it tells us in the question, plus 106. So I just write 106. And that is equal to bonds broken, energy required to break the bonds, CH4, so 413 times by 4, plus H2O. Well, if we draw out H2O, got two H's, water, so it's going to be 2 times by 463 minus bonds formed. Well, we've got the Y, the C double bond O, that's what we're trying to find, plus 3H2. Well, it's not actually 3H2, because if we look at it, hydrogen and hydrogen. No, it is 3H2. So it's just going to be 3 times by 463. So if I put the first part in my calculator, I get 2578. So 106 equals 2578 minus y plus 1389. So we're going to get 2578 minus 1389, 1189. 106 equals 1189. And don't forget, this y is also negative, minus y. So y is equal to 1189 minus 106. 139, so 2578 minus 139, 189. Should get 1064. 1064. Let's think about it. 413 times by 4 plus 2 times by 463. 2578 minus y plus 3 times by 463. 463 is 436. 1308. So confused between the HH bond enthalpy and OH bond enthalpy. That's what I did. So then, yeah, 2578 minus 1308, 1270. We obviously got a minus y, so we add y. Therefore, y is equal to 1270 minus 106. One second. 2578 minus 1308, 1270. 1270. Yeah, either way, we get 1064. I don't know why it's a bit complicated. Then question 23. 2 moles of ideal gas are stored in a flask of fixed volume which should volunteer lead to the greatest increase in pressure. Increase in temperature from 20 degrees Celsius to 200 degrees Celsius. Definitely not A, that's for sure. Because if we're going from 200 to 200 degrees Celsius, right? That's, well, in Kelvin, that's from 293, because we add 273 to convert from degrees Celsius to Kelvin. We add 273. So that's 293 to 473. And that's an increase of 1.61. Yeah, so we've increased temperature by 1.61. In this case, we're adding a number of mole gas. We're going from 2 to 3. Well, we're timesing by what? 3 over 2, so 1.5. Adding 1.5 moles of argon gas, we go from 2 to 2.5 and increasing the temperature. So that's 1.25, that's the times by 1.25. But we also have gone from 293 Kelvin to 150 plus 273, 43 Kelvin. And that is an increasing factor by 1.44. So now what do we do with both of these? Well, we do 1.25 times by 1.44, which give me 1.80. And then for D, well, with removing 0.5 moles, we'll go from 2 to 1.5, so we're timesing by 0.75, and we're also going from convert to Kelvin and see the increase, and we should get 1.46. So the answer is C. That's the greatest increase in pressure of time by 1.80, and that's the end of the multiple choice questions.